Hello dear students, welcome to Hybrid Learning. Now today's video is about refraction of light through a glass slab. So let's get started. In the last video, we spoke about refraction of light in three different cases. First one was when you go from a rarer to a denser medium. Second one was when you go from a denser to a rarer medium. The third one was when your incident normal to the surface. We are going to use the same concepts and we are going to apply here today. Okay, let's understand. ABCD is a rectangular glass slab. Mu is the refractive index of the glass. In some books, the notation can be given as N, so you can use it as it is. T is the thickness of the glass slab. Since it's rectangle, so AB and DC will be parallel to each other. Now, this is the incident ray, the red line, the incident ray which is incident on AB. Okay, this is the normal which is drawn at the point of incident. Now, this is my refracted ray. Okay, so I is my angle of incidence, R is my angle of refraction. So you can understand, since it is air outside and this is glass, so this is my rarer and this is my denser medium. So when we are going from rarer to denser medium, the light ray will bend towards the normal. So if you can see here, that is the same thing what is happening. Okay, and now when it is incident on the surface DC, this is the point in which it is incident. We have drawn the normal, and this ray which is coming out is called the emergent ray. And the angle made by the emergent ray with the normal is called the angle of emergence, that is E. So we have here three angles. Angle I, which is angle of incidence, angle R, which is the angle of refraction, and E, which is the angle of emergence. These three rays are important. Now, what is happening, if you just understand, suppose this is the incident ray, okay? Now, if there wouldn't have been any rectangular glass slab, the light ray would pass as it is, that is through this dotted straight line. So this has been denoted by the extended incident ray. So what you can understand here, if we try to correlate our emergent ray now after refraction and this extended incident ray, we could see that it is just slightly displaced in the sideways direction. That's why we say that in this case, in a rectangular glass slab, the light ray gets laterally displaced. Laterally displaced means shifted in the sideways, okay? And this distance between them is known as D. So we can do this experiment and we can find out the width of the lateral displacement. It's a very important topic for all the grade 10 students of all the boards. This is an important point because in a rectangular glass slab, you cannot see any dispersion which is happening. Okay, you're not seeing any dispersion here. Only the light ray after refraction, which is coming out, that is my emergent ray, is getting slightly displaced. So this is a very popular experiment, very important experiment, which you can do it in the lab. And you can also see that you can get the value of displacement D. Now, what are the factors on which this lateral displacement depends? It depends on definitely your angle of incidence, because once you change this, your E will definitely change. Okay, so I will be very important parameter here, and obviously your mu, which is the refractive index of the medium, and the T, this is the thickness of the slab. If you change the width of the slab, obviously the whole refraction part will change, and this value can also change. So this is the important point. Hope you understood the topic. If you have any doubt, please let us know in the comment box. Bye bye. Let's meet up in the next video.